Okay, so we've installed packages that we need, we've imported the libraries that we need, and we've set our working directory. Now we can start playing with some of the data files that we have saved. So the first data type we're going to work with is a points data file. So let's create a title here, points. And if we add a couple more bracket number signs, we can actually create a little header at the bottom here. So we know that we're working with points. Okay. So we have a lot of different data types in the data folder, and the first points data file is a CSV file, and it's a census of each squirrel in Central Park in New York City, which I think is very cute, and I think it'll be fun to play with this. So we're going to call this squirrel underscore census. And we are going to use the read CSV function to import the CSV into our working directory. It's a pretty long file name, so I'm going to just copy it directly from the folder and put it into the brackets here because it's a bit too much to type out. Okay, so there is the file name. It's called 2018 Central Park Squirrel Census, and we can go ahead and run that. And there we go, it's successfully imported. So why don't we take a look at our environment, which is on the bottom left-hand side, and you can see it right there. So let's click on that. It'll open up the viewer in RStudio. I'm going to close this, and you can see what's inside the CSV. We have an X column, a Y column, an ID for every single squirrel, and then a bunch of other parameters that we can play with. So I think this is really nice. It's a really great points data set that we can play with. And you can also see what they were up to, which is very cute. You can see whether they're running, chasing, climbing, eating, or foraging. Super cute. You can also use the view function to view the data frame. So you type out view, and that's with a capital V, and then you type out the name of the data frame that you want to view. So we're using the squirrel census. Run that, and it opens up the same page. So it's the same thing. It doesn't matter how you get there. So let's turn this into a spatial data frame, because right now it's still a 2D data frame. It's just a CSV file that we've converted into an R data frame. There's no spatial component yet. There's no geometry yet. We have to tell R what they should use for the coordinates. So we're going to use a function from the SF package, but we need to name the variable first. I'm going to call it squirrel SF. The function that we're using is called st_as_sf. We're going to specify the name of the data frame that we're referencing. So we're telling R that we want to use data from the squirrel census data frame to create our spatial vector layer. We then need to specify the coordinates. So we're going to use the coordinates argument. In the coordinates argument, we need to tell R what the X and Y coordinates are. And what's convenient for us is that in our data frame, if we look at it again, it tells us X and Y. So we just input the X and Y columns. If you have lat long data, you can input lat long data, but for us, it's really just an X and Y. So the X column is called X, and then we have Y. We're also going to specify our AGR, which stands for Attribute Geometry Relationship, and that's just telling R how the different variables in this data frame, such as hectare, shift, date, age, fur color, how does that relate to the geometry of this data frame? And for us, it's constant, it doesn't change. So the age is not going to change based on the location of X and Y for this data frame. So we're just going to do AGR and keep it constant. There are other options, and if you're curious about that, you can always open up your console and then you can type out st as sf, and it'll give you some more detail on what this parameter means. And I think it's definitely worth a read. It'll give you more information on what this parameter means. And there are options where you can change the relationship between the column variables and the geometry. So here you can see AGR is it inputs a character vector, so it has to be a string like this. Here you go. So here under details, it specifies what AGR stands for. So it's the attribute geometry relationship, and it specifies for each non-geometry attribute how it relates to the geometry. And the options are constant, aggregate, and identity. Okay, so now that we've specified all the appropriate arguments in this function, we can run it. Easy peasy, it ran. Let's explore what the data looks like. So I'm just going to type in squirrel SF. And we have a lot going on here. But what I want us to focus on is the first couple parameters. So I typed in squirrel SF, and you can see that it's now a simple feature. SF stands for simple feature. And there are 29 fields. And when they say fields, they're basically referring to all the column data that's available. And we have data for just over 3,000 features. So that tells me that there's 3,023 squirrels in this data set. We have XY data as our dimension, and it's point data. So R was able to pick up on all of this just using the information that we gave it. And these are the limits of the data. So these are pretty much the limits of Central Park, essentially. And you'll notice that in the data frame, you can see all of the columns that are available on the data frame from the CSV, except for X and Y. So our X and Y column is no longer available. If you scroll down, you'll see that there's now a new geometry layer. And for each row in the geometry column, you have a point. And that point represents the lat long data that we specified in our SF function. So you'll notice for the first row, the X and Y column match exactly what we have in our CSV. And that means that we were able to create this geometry accurately. So that's the difference between the simple feature that we created and the original CSV. And it's important to do this comparison to make sure that your geometry is being created correctly.